All right, so I got the recorder started and I am going to bring the web page for this class into view. There we go. All right. Okay, so if there are no questions about pointers, we are going to start on characters, C strings, and more about the string class. I got this presentation file from her, which apparently is coming from the textbook. So I'm assuming that you all have access to the same presentation file. Is that correct? All right, very good. So then we're going to get started with chapter 10, which is about characters, C strings, and more about the string class. So they are all slightly different concepts. All right, section 10.1 is about characters. Okay, so did she talk about what a character is? Yes or no? Yes. Okay. All right. Very good. So a character is a 8-bit, sorry, is a 8-bit quantity that is used to specify a character, and a character is typically something that you can display on a dumb terminal, or you can send to a printer or stuff like that. So I'm just gonna go ahead and start with a demonstration of what a character is and what ASCII is about. Did she talk about what is ASCII? ASCII? Okay, all right. So I'm going to show you some tools that she probably typically won't use, because of the way that I teach my classes. I tend to use Linux. So this is a Linux, what we call a command line interface, and within the command line interface of Linux and most Unixes too, you have access to a manual page, and on the manual page, there's one page for ASCII. So this is typically, what the way we look at the ASCII table, so to speak. So if you want to look up like lowercase k, okay, this is the character. It is represented by, okay, there are three columns here. The one column that you guys are more familiar with is going to be this column here, the middle column. It is 107. Okay, so 107 has the same bit pattern that is used to represent the letter K, which basically means if a computer send over the binary bit pattern that is corresponding to 107, the printer, an old dumb printer, is going to print K. Okay, so is that okay? Is that understood? What ASCII is for? Okay, all right. And the other two columns, in case anyone is interested, this is in hexadecimal, which is base 16. So 6 times 16 plus 11 is 107. So that's what 6b is representing. And then this is 153 in octal. It is an octal number, meaning it is a base 8 number. So have you guys talked about bases other than base 10? No, not yet. Say again, please. Outside of the class, you know something? Okay, cool. So, since she hasn't really talked about, base 8 or base 16, I'm not going to go there. Okay. So, we are going to take a look at some, I will kind of illustrate this point. Does everybody understand what I mean when I said the binary bit pattern of 107 is going to be the same thing as the ASCII code of K? Is that understood? Or do you guys want a program to illustrate it? Would it help? Okay, all right, so let's go ahead and do that. All right, so this is the way I write programs. Okay, I write programs on the command line. You don't really have to do the same thing that I do because I use Linux. However, okay, what the program is illustrating is probably important. So what I'll do is I will give you a very quick sample program. I'll just call that char.cpp for C++. And then we are going to, well, okay, we'll just write a tiny little program here. And we have a char type, okay, and we'll call the variable x, and then we'll say x equals to 107, which is the ASCII code that we just looked up, which is the ASCII code of what again? Lowercase k, right? Okay, very good. And then the program returns right away. So when you look at this program, you ask, how can this program possibly have any output? There's no cout anywhere, there's no printf anywhere. Well, the idea is I don't even need to print or cout. Okay, so I'll show you a really useful tool for doing this sort of thing. It is not a tool that you probably have to understand how to use for now, but I think over time it is going to be a useful tool. So I'm compiling the program right now using on the command line. Most of you use either Coblox or Online GDB or a tool like that or VS Code. You just click a button and it does everything for you. I don't do that either. Okay, I use command line for just about everything. So now the program is compiled. The executable is called char, and GDB is going to be my debugger. So for those of you who look at this and go like, I've never seen anything like this, well, guess what? This is behind VS Code. This is behind Coblox. It is also behind Online GDB. How else do you think Online GDB gets its name? Okay, so this is actually the actual tool that I have, it's local to my computer. Okay, I don't need internet access to actually do this part. All right, so we're going to list the program. This is the list of the program. It's hard to see the syntax highlighting. I'm putting a breakpoint on line 5, which is the return 0, and I'm just going to run the program. So if I print X, it is printing that it has a value of 107, which you can use as an integer. In other words, you can add, you can subtract, you can multiply, you can divide even, okay, with that value. But at the same time, it is also interpreted as K. The lowercase letter K is also having the same code as 107. Are we doing okay so far? Okay. So what else can you do with integers in addition to adding, subtracting, multiplying, dividing, that sort of thing? What else can you do? Okay, have you guys talked about these operators? Comparison, right? So as it turns out, you can compare characters as well. Has Momena talked about how to compare characters? She did. Okay, all right, excellent. So that means you can have ordering between characters, which also means you can order strings, okay? But string compare is a little bit different compared to character compare, so we'll talk about that in just a little bit, okay? So here we go, okay? This is all the sample program is supposed to show is 107 and lowercase k are really the same thing. All right, so now we are moving on to character testing. There are a whole bunch of built-in functions that can do that. So you have is alpha that determines whether a character is a letter, which means it is from A to Z, lowercase or uppercase. The next one is alnum, which is alphanumeric. Okay, so that means it's either a digit or a letter. So it can go from 0 to 9, or it can be A to Z lowercase, or it can be uppercase A to Z, and so on. So now the question is, if these functions are not given to you, do you know how to write these functions? And how would they look like? So I'm gonna pick one which is alnum, okay, and I'll show you how we can write the code for is alnum, okay. So I'm focusing on just this particular function here. So it is true if and only if the argument is a letter or a digit, false otherwise. Okay. All right, so there are two ways to look at this particular statement. They could have just said, true if and only if argument is a letter or digit, then they don't have to say false otherwise. So the difference between if versus if and only if is actually kind of important. I'm not going to talk about it in this class, but by the time you get to 440, which is going to be one, two, about three semesters, you will be in CISP 440, and that's when we'll talk about if and only if versus if. Okay, but for now, I think you guys understand what this table is trying to say. All right, so I'm going to implement is our num, okay, and we'll take a look at the implementation and see if you guys have any questions about that. So I'm going to just name the file as is our num as a C++ file. It returns a Boolean type, and I really cannot use is alnum because it is colliding with a name in the library. So I'm just going to say this is text is alnum. Okay, because I cannot just use the other name. All it takes is a character, const char, give it a character of x, and now I want it to return the true if and only if x is within the range from 0 to 9, lowercase a to z, or uppercase a to z. So the question is, how do we do this? Okay, so I'll let you guys think about it for now, and then I'll go ahead and just write the rest of the program. Okay, x, y, z, x is tax is num, and we'll check out what is 5. Okay, and then y is going to be lowercase t, and then we have z being a punctuation mark. Okay, we'll use exclamation here. There we go, and then return 0. All right, so have you guys thought about how to write this function? What do you need in this kind of function? What kind of construct do you need? If then else, okay, that's one way to do it. What if I were to tell you you don't need conditional statements for this? Hmm? Okay, you need a little bit more than that, right? Because you need to check a range and then you need to check another range and so on. So have you guys talked about the ternary operator? Yes, the question mark and the colon. Okay, I see people nodding. Okay, so let's put that in use today. Okay, we are not going to touch conditional statements to implement, is our num. Sorry, it is not a statement. It is an expression. Yeah, big deal. It is a big deal. Okay, if you are a compiler, a statement versus an expression are two entirely different concepts. So it is a big deal. All right. So we're going to use a single return statement with a complicated expression to do this. So we're going to say, okay, we first have to ask, is it a digit, right? So a digit means 0 as an ASCII code is going to be less than or equal to x. And then we also need x to be less than or equal to the last digit, which is 9. So are we agreeing that this line here, this expression, is true if and only if x is a digit from 0 to 9? Okay? That's the ASCII code. It has to be greater than or equal to the ASCII code of 0, but it also has to be less than or equal to the ASCII code of 9. Is that okay? All right. So what if it is not a digit? Well, if it's not a digit, we got a second chance to make this expression true. Actually, as it turns out, I lied. I don't even need ternary expression. I just need regular OR. So now we just compare to lowercase a, like so, and then lowercase z, and then we have another OR for the uppercase. Okay, and that would be uppercase z. There you go. All right. So do we have any questions about the implementation of my own is alnum? Is that okay? All we need is OR, okay? Do we have any questions about the logical operator or the operator and? Do we understand what these two symbols are representing? Ampersand, ampersand versus vertical bar, vertical bar. So is that concept okay? All right. All right. So let's go ahead and just run this program, okay, for now, and then we're going to test it on something else. So we'll go ahead and once again compile the program. This is a C++ program. So is num is that's the executable name, and then this is the name of the file. GDB is num. There we go. And it's really hard for you because it turned on, the syntax highlighting. Let me see how we can turn off syntax highlighting in GDB. So how do you think I will find out how to turn off syntax highlighting in GDB? Better, Gemini. Let's boil some water. Let's go boil some water with Gemini. You all have access to Gemini by now. Do you know that? Some people nod and some people turn their head. Okay. So the state chancellor's office has already arranged a deal with Google. So all students, staff, faculty member, and administrator of any community college in California now have access to Gemini for the next 3 years. Okay, so that means you have access to it too. If you sign into apps.losrios.edu with your student account, you can now go to gemini.google.com and use Gemini. Okay, but there's one caveat. Okay, all the conversations that you have, you cannot delete. So be very careful what you ask in Gemini, okay? Because if your professor is suspicious about something, the professor can ask the dean, and then the dean can ask people who work for IT, and if everything is approved, they can get a full log of your conversation with Gemini. Well, just use it wisely, okay? As with everything else, do it in a wise fashion, okay? Just don't do it in a way that you go like, "Oh, okay, I don't really want other people to see this conversation," okay? So keep those conversations off of your school account, okay, at least. All right, so I'm gonna ask a question that I don't mind asking using my school account, which is, how do I turn off syntax highlighting? Highlighting in GDB, and I think that should be sufficient information. I have identified in what environment what I need to do. Okay, so we'll go ahead and see whether it comes back with the right answer. Sam Altman, do you guys know who is Sam Altman? Okay, some people nod and some people do not seem to know. So Sam Altman, who is the CEO of OpenAI, has basically said when people asked him what is the most important skill set for this century, what do you think that was? Okay, I'll let you think about it. It looks like you might know the answer. Okay, he said, the most important skill set is to know what question to ask. Okay, it's what question to ask. So keep that in mind. Okay, because I think that is actually true for the most part. All right, so I'm going to try that out. I cannot remember the command again. Set style sources off. Okay, I'm going to do the super lazy thing. Copy and paste. There we go. And we'll list the main program again. Woohoo! Yes. Syntax highlighting is off. We'll put a breakpoint on line 12. And what do you think would be the values of what is the value of x? Okay, x is a Boolean variable. It is text is num5. So the question is 5 alpha numeric? Okay, that should be pretty apparent. It should be true, right? Okay, there we go. Oh, okay, I haven't run the program yet. I have to remember to run the program first. There we go. Okay, so x is true. What about y? Should y be true? It's lowercase t, so it's lowercase t alpha numeric. Okay, it should be. Okay, there we go. And we're going to try z, and z is false because an exclamation point is not alphanumeric. All right, so you guys go like, Tech, you spot checked your own code with 3 different characters. Seems to be working okay, but how can we be sure that your code is working for all the possible characters? So how many possible characters do we have? How big is a char type? How many bytes is a char type? Is 1 byte. Yeah, okay, very good. So with 1 byte, what is the range of value that it can assume? 255 is correct. Okay. Well, as it turns out, char is signed. Okay, which means you only go up to, if you look at the ASCII table. Okay, let's go back and look at the ASCII table again. So man ASCII. So the ASCII table only goes up to 127, which means we do not use the negative values of a char as a character. So we only go from 0 all the way up to 127. So what I'm going to do now is to check whether my code is going to work for all possible cases. Now, this is typically not the way you would check whether a program is working or not, but in this case, we can kind of do it that way. So I'm going to take this out, okay, and I'm going to have to pound include. Well, I'm going to do it without the pound include and then have GBD or G++ to complain about it. So what I'm doing now is to say, okay, let's set up a loop here where I use a character type ch, okay, this is my local variable, and it's going to start with a value of 0, and as long as ch is less than or equal to 127 plus ch, okay, we auto increment, and then all we want to do in the loop here is to see whether the two functions give me the same result or not, okay? So we'll go ahead and do we can use something like this, okay? Bool error equals to false, and then over here we just say error equals to error, or so if my function, which is tax is alnum using whatever character ch is, if it returns anything that is not the same as the original is alnum, that means my implementation is faulty. Okay, so it only has to be true once in order for error to be true like forever. Okay, for the rest of the loop. All right. So now the question is, do you see a problem with this loop? Hmm. All right. So I'll give you a hint. What is the range of value for a char, which is an 8-bit signed integer? Has that topic been brought up? Like, what is the range of value that can be represented by an 8-bit signed integer? Okay, so what is that range? It's negative 128 to positive 127. Okay, wait. It's negative 128 to what again? 127, right? So when you look at this, don't you think this less than or equal to is going to be true all the time? Because every single 8-bit signed integer is guaranteed to be less than or equal to 127. Hmm. It doesn't stop, it just wraps around. Have you guys talked about the wrapping around effect? Like how when you add 1 to 127, you get negative and 128? You guys haven't talked about that? Sorry. So this condition is guaranteed to be true all the time. Now let's see whether that is the case or not. Okay. So we are going to compile the program, let it run, and see whether it stops. So we'll go ahead and gcc. Oh, I can just repeat the previous command, g++. Nope, because it says it's an error because I forgot to pound include. So the way I can find out what to pound include is simply to man the function itself, and it will tell me that this is in a ctype.h file. Okay, that's the header file, ctype.h. All right, so let's go back and re-edit the file, pound include ctype.h, recompile the program, gdb is num. Okay, list the program. Oh, okay, I forgot that I want to turn off syntax highlighting. And let me go back to the browser. Okay, copy and paste again, like so. Okay, list main again. All right. So what I'll do is I'm putting a breakpoint on line 14, okay, which means when they get to line 14, it's going to stop. So No compiled code for line 14 in the current file. Mm, that is odd. Hmm. Okay, let me try that one more time. Okay, list. It definitely has a line 14. So B14, it doesn't like it. No compiled code for line 14 in the current file. That is strange. Okay, what about other lines? Line 12? Oh, it doesn't have a problem with line 12. Hmm. What about line 15? Nope, nothing on line 15 either. Why is... Did I recompile correctly? Yes, I did. Nope, still doesn't like it. Darn it. All right, so that's okay, because my main point is the program going to terminate? So I can just run the program by itself and see whether it terminates or not. Is I don't know, and it does not terminate. The program just keeps going and going and going because every single 8-bit signed integer is less than or equal to 127, right? So how do we fix this problem? If we want to fix this problem. Well, you can check whether it's negative because as soon as it goes negative, you can exit the loop, right? So it is very counterintuitive if you do it that way, which means it may not be the best way to express it. So if I want to fix the program, I basically have to change this condition so that I can say, okay, if ch is less than 0, we're going to exit the loop. Which also, if you look at it, it doesn't make sense, right? If you present this program to a mathematician, the mathematician will ask, "Are you crazy? This loop is crazy. Okay, this loop should not exit. The other one should, because to the mathematician says it starts with a value of 0. And what do we do for each iteration to ch? We increment, right? So if it starts with 0, the next value is going to be 1, and then a 2. It's not going to be less than 0 ever. But since we are not mathematicians, what are we? We are computer science people, right? We are developers. We are software engineers. We go like, no, this is going to work. Okay, so we'll check out why this is going to work. So we'll go ahead and recompile the program, and then we're going to rerun the program without the debugger first, okay, just to make sure that it does terminate. Not a problem, okay? So now we're going to run it with a debugger. Hopefully it's going to run. I have no idea why it wasn't running before. So we'll take a look at line 14. Okay, this time it's fine. Okay, I have no idea why it didn't work the last time. Run the program. Okay, and now we are at the breakpoint, and I just have to print error as a local variable. It is false. So that means for every single instance, for every single possible character, the implementation of my is alnum is identical to the actual is alnum. Are we doing okay so far? Okay. So now that my question to you is, do you do stuff like this on your own? In other words, you look at a function that, okay, let's go back to the presentation. So you look at a function in the presentation, let's just say, another one is lower, okay? So when you see is lower as a function, you read what it is supposed to do. Do you think about how you can do it yourself? So yes, okay, we have some, yes, kind of, okay, which means you think about it, you may not actually do it the way that I did, right? But you think about it and go like, okay, if I were to do this, how am I going to do it? So that would be a good sign, okay? So for people who have not considered doing that, I highly encourage you to think about every time you encounter something, you think about how am I going to do it? Okay, do I have I learned enough material to do this myself? Because the moment you do it this way, you just expanded all your homework assignment. You expanded what you can do to make sure that you're learning what you need to do in order to kind of get your degree here and then move on. All right. So, okay, so let's move on to the next slide. I have a lot of things that I want to say, but I don't have enough time to do it. All right. So this is a really short program. It's just checking out. You can type any character in, and it will tell you whether it is alphanumeric, whether it's a digit, and so on and so forth. I consider these programs to be really boring, so I'm not going to talk about it. All right, case conversion. Okay, so how do we do case conversion? And what is case conversion, by the way? Can someone describe case conversion to me? But you change the case, right? So if you have a lowercase, you might want to keep it at lowercase. You want to change everything to lowercase. Or if you start with an uppercase, but you want to change it to lowercase, you can change it to lowercase. Very good. All right. So there are functions to do this already in C type. Okay, so we go to huh? Yeah, to upper and to lower. Okay. So now the question is, okay, exactly what do they do? And even if we know what they do, um, what does the specification look like? So right here we have the description of the function. To upper will do if char argument is lowercase, return uppercase equivalent. Otherwise, return unchanged. Okay, return the input unchanged. So that's one way to describe it, and it used a few examples to describe it. So I'm gonna kind of deviate a little bit here, and I'm gonna use the man page to find out, okay, how is it described in the man page? Okay, so in the man page, it describes it as the function converts lowercase letters to uppercase and vice versa. If C is a lowercase letter to upper, returns its uppercase equivalent. If an uppercase representation exists in the current locale, okay, so that's a term that you guys might not have encountered. Otherwise, it returns C, which is the argument itself. And to upper underscore L function performs the same task, but it uses the locale referred to by the locale handle locale. So locale is basically it's the language setting. Okay, it's related to the language setting. So what you're dealing with here is called the UTF-8 character set. Okay, it's an 8-bit thing. But we also have Unicode. So what is Unicode? As Momenta talked about Unicode, okay, a little bit. All the emojis are Unicode. The reason why you can type Unicode and why you can type emoji in a text file is because of Unicode. Okay. You can also type a whole bunch of other things like Klingon. For those of you who are Star Trek fans, you can actually write in Klingon if you want to. Okay. I don't see anyone being curious about what Klingon is. Think of it as a foreign language. All right. So I want you to think about this, okay? How do you implement your own to upper function? Okay, so this is the kind of homework assignment that is not from the professor, okay? If you can generate your own homework assignment, you can learn a lot more, okay? You get a lot more practice. Yes, sir. Hmm? Yep, I am using Vim. Yep, well, okay, yes and no. I'm using NeoVim, which is based on Vim. Yes. I grew up with Vim, so I'm old. So I've been using VI editors for, oh, that's an easy subtraction, 40 years. Yep, yep, 40 years. So, this is why I use Vim because, I can do it without thinking about what key I need to press because it's all muscle memory to me. Sure, yeah. All right. So once again, home self-assigned assignments. Okay, think about how to do something. When you encounter a function like to upper, which is a very easy function to implement. Okay, so you should have learned everything that you need in order to implement to upper. Okay, so doing this kind of exercise, when you're not asked to and there's nothing to turn in and it's not done for grade, is actually useful to you. Okay, I know some people are not thinking in that direction, which is okay. Okay, but I'm just telling you that, in the long run, being able to generate your own homework assignment just by being curious of how do I do something like this? Do I have enough tools to do this already? That is ultimately useful in the long run. All right, so there we go. We continue our slides. Okay. All right. There's not much to say here. This is pretty kind of boring stuff. And then we have to lower, okay? And then we have 10.3. I mean, I'm sorry, I just cannot resist it. I have to do it. I have to show you the implementation of to upper or to lower. Pick one. Which one do you want me to demonstrate? To upper? Okay. So we're gonna, kind of try this out. To upper, okay? So we'll say, to upper dot cpp. All right. So what type is it going to return? Okay. So, because when you write a function, you always have to think about what is the return type. So what do you think is the return type of to upper? A char. Very good. Okay. So we use a char as a return type. And I'm going to use a name here. I would say it's T to upper. The first T is tac, okay, my first name. And then what do we pass as an argument to upper? What is the type of the parameter? Okay, so we could char x here. Can we do better? Const. Okay, so what is the difference? What is the difference between const versus non-const parameters? What does the const thing say? Yes, it says constant, right? Yep. So what does it mean to the compiler? Yes, non-changeable in the function. So the function is not supposed to change x in this case. All right. So it's a minor thing. Okay. It seems really kind of minor because we're not going to change it anyway. So why is this a big deal? It is a big deal because it helps with the optimizer in the compiler. So functions that have const parameters can be optimized better than functions that are not that do not have a const parameter. So a lot of these little things, is actually significant in the long run for for other reasons, but sometimes they are not really talked about in a class like this. All right. So how do we do this one? Let's do it in a single return. Okay. So if we're gonna do it in a single return, that means this time we have to use the ternary operator because we have to first determine, is there something for me to do with the character x? Does that make sense? Okay. So if I'm turning something to the uppercase, um, okay, so I'm gonna do the usual thing that I usually do, which is to give you all the three blocks here. So the question is, what block is going to be the then block, what is going to be the else block, and what condition do we want to check? We'll start with the condition. There are two ways to look at the condition. Either you say, oh, if it's lowercase, we got something to do, right? Or if it is not lowercase, then we don't have anything to do. So you can start with either one. So which one do you want? Do you want me to check whether x is lowercase or it is not lowercase? We can do it either way. Just pick one. Lowercase. So we want to confirm x is lowercase. Okay, so that's a easier. They're equally easy to do. So we have already looked at range checking in the previous program. So we're going to do about the same thing here. So we just say, okay, if it is greater than or equal to lowercase a, and it is less than or equal to z, then it is a lowercase character. Is that okay? So that means this block of code has to do the actual case conversion. And then this block over here is just like, ah, there's nothing for me to do. This is not a lowercase character. Just return it. All right. So now the question is, how do we turn a character from lowercase to uppercase? Because we just confirmed that X is a lowercase character, so we have to turn it into an uppercase character. How do we do that? Yes, you can subtract from it. Yes. So what do we subtract from it? That's okay. You don't have to remember. Okay. So what we subtract from this would be the same thing as the difference between uppercase A minus lowercase a. Hmm? So this way, I don't even have to look up the ASCII table, right? Because the difference between uppercase a and lowercase a is the same as the difference between uppercase b and lowercase b and so on. So when you subtract the ASCII code of lowercase a from X, then you get the actual difference that you need to add back to the ASCII code of uppercase a to get to the uppercase version of X. Okay, it is well, it is as smart as it is lazy because I don't want to look up the ASCII table. So uh, sometimes laziness is the engine of being do things in a smarter way. All right. So we are going to do about the same thing. This time I'm not going to test everything. I'm just going to give you a few, examples. X, Y, Z again. Okay. X is T to upper. We'll actually pick a lowercase character this time. Okay. We'll pick lowercase f. Okay. And then the next one, we'll pick an uppercase character. We'll pick uppercase K. And then the last one, we'll pick something that is not even a letter. Let's say the question mark, okay? And then we'll have a return 0. We have to change the variable names, X, Y, Z. Okay, oops, what? Z. There we go. All right, G++ to, oh, dash D dash O to upper, and then to upper O. The wrong file name to upper. Forgot the file name did not have an extra T in front of it. There we go. GDB to upper. Okay. I think this is what is causing the problem. We'll see. Put a breakpoint on line 11. Whoops. That's definitely my fault. Nope, that was not it. Run. Okay. So X should be uppercase F. Ooh, it is not. Okay, the program is not working. Y is still uppercase K, and then Z is the question mark. So it wasn't working. I messed up. Okay, this is great. I like it when my program does not work. Why do you think that is the case? I get to show you guys how to debug a program. Okay, that is actually important. Okay, what is debugging? Figuring out why a program is not working the way it's supposed to, right? So in order to debug a program, the first thing we need to know is what the program is supposed to do in the first place. Do we know what the program is supposed to do? I think so. Okay, let's hope that is the case. So that means, we just have to figure out why the code is not doing what it's supposed to. And I think probably I have the subtraction in the opposite order. That's just my suspicion. So we have to, yep, it's in the opposite direction. So the better way to look at this is to do the subtraction first, so that lowercase a becomes 0, lowercase b becomes 1, and so on. And then we add this back to the ASCII code of uppercase A. So if you put parentheses around it, it is even easier to see. So the inner parentheses would give me 0 to 25. And then once we add 0 to 25 to the ASCII code of uppercase A, then we should get uppercase A to uppercase Z. Okay, so it was my problem, okay, but I spotted it and I fixed it, hopefully. So we'll go ahead and test the whole thing again, and it doesn't like it because I mismatched my parentheses. That's an easy one. I should have paid more attention to the editor because it highlighted the extra close paren that has no beginning to match it. There we go. There we go. GDB to upper. There we go. Uh, we have to turn off the syntax highlighting, list the program, put a breakpoint on line 11, run the program, print X, uppercase, print Y, uppercase, print Z. It is not anything that has an uppercase. All right, so the program is working now. Yep. But it's doing this kind of thing. It's encountering problems when your program doesn't work and you have to think about it and you have to debug it. That is what is giving you the extra skill set to beat the next person who also turned in a resume for the same job that you turned in your resume for. Okay? And you'll be asking, so who are my competition? Just turn around. That's your competition. So the question is, do you want to beat the competition? Okay, then you have motivation. Then you know the motivation because it is important to understand that motivation. Um, all right, so I cannot resist this. I know I'm going to use up some class time. How easy or difficult is it to get a job as a software engineer? Okay, so we got hard. Anyone else? Easy. Okay. All right. So we got easy and we got hard. So which way is it? Well, it depends on the era. Depends on the time. Okay. I didn't specify the time frame. Okay. When I was a student, okay, when I was an undergraduate student in 1985, okay, it was super easy. Okay. You get a bachelor's degree in computer science from any university, and then companies will be lining up to hire you. You get a master's degree, you're golden, man. No problem finding any job you want to. Okay, you get hired by HP, and guess what? HP back in those days, they don't really care about how good you are at your job. You can suck at your job. All they do is go like, well, Tech, I see that you really suck at writing this kind of program. Let's see if you will do better with the other department. So they would literally take me to another department, try that out, see if I am a better fit over there, and they'll try out the entire company before they fire me. Okay. Well, guess what? Those days are long gone. Those days are long gone. Okay. These days, how many people have heard about? Okay, I see people are getting excited about all this. Very good. Okay, are you okay? All right. So these days, who has heard about the company called VSP? As in the letter V, the letter S, and the letter P, all uppercase, by the way, since we're talking about uppercase. VSP? No, nobody. Okay, somebody. Yes, it's a exactly. It's a vision insurance company that is pretty much local to Sacramento. Now they're trying really hard to expand, okay, but nonetheless, it is still a fairly small company. Okay, so can anyone imagine the number of job applications they get for a single software engineer position? 50,000. 50,000. Yes, that is the entire population of Davis. Okay? Okay. So VSP, I mean, you guys did not seem to go like, oh, VSP, we know what that is. You guys would say that to Google, you would say that to Facebook, you'll say that to Grok and so on. Not Grok, what is the company? XAI. Okay. But VSP is kind of like a local, homebrew, Sacramento-ish kind of company. 50,000 job applications for one single job. And guess what? They do not like Californians. They want to hire people who are out of state because apparently it is less expensive to hire people out of state. Yes. So, because, yeah, yep. Because I think in California they have to pay extra whatever, to the franchise tax board and all kinds of stuff like that. So they actually want to hire people who are actually out of state. So move to Nevada first if you want to get that job. Okay, move to Nevada, just across the border, somewhere in Tahoe. Okay, um, but 50,000 job applications. I'm not kidding you. So the competition is fierce. Okay, I'm saying all of this because I want to motivate you to do the extra step. Okay, to understand programming, to practice your skills, and so on, because you're gonna need that. Okay, and I even haven't talked about AI yet. Okay, all right. So now that we are properly motivated, let's move on. So we got, to lower, which is kind of the same thing, except it changes to lowercase. Then we move on to the next section, which is talking about C strings. So now things get a little bit more interesting because a C string, which is originating from C and not C++, is essentially looking at an array of characters with one little thing that is super important. The content of the string is null terminated. So what do we mean by null? So, in order to specify the string that says, hi there, exclamation point, you need one extra character for the null character. The null character is nothing more than just zero, but it is not the digit zero, it is the value zero, okay? Because they're different. All right. So we are going to, kind of take a closer look at a C string and go like, I'm not really sure what that is. Okay, so we'll take a closer look. So we'll go ahead and write another program to look at a C string. Okay, so we'll start with okay, we'll just write the program called cstring.cpp. And once again, I will rely on the debugger to help me visualize values in the strings. This one may or may not work the way I intend. We'll find out. Okay, so I'm first going to create an array of characters. We'll just call the str for string, and we'll just say that it has 32 characters. Okay, so it is uninitialized. Okay, any local variable or global variable in C or C++ are not assumed to be initialized. Is that okay? Now, why is that point important? Because in most scripting languages, such as Python or JavaScript, variables are quote unquote initialized when they are first created. Okay, they have a very specific value in those, but not in C and C++. Okay, they can be anything when you first create the variable. So there we go like, okay, so let's just start with this. Okay. Okay, what do you think that would do? Line 4. The string becomes empty. It is an empty string because the first character of the entire string is a null terminator. So that means there are no characters before the null terminator, which basically means the string itself is empty. It has a length of 0. Okay, so if you are to print your str at this point, it would print nothing. Are we good with that? Okay. So if you're not convinced, okay, this time we'll go ahead and I'm old school, so I'm going to use something that your professor does not use. I'm going to use standard input output. And to do that, I'm using printf, which means print formatted. So in print formatted, you basically give it a format string like so, and then you give it a placeholder kind of like this for a string, and then you give it another, quote, this is just the terminator of the string itself, and then this is the actual double quote to end the format string itself, and then you give it the string that you want to print. Okay, so we'll just try out this program. Okay, so have you guys talked about the concept of printf or print formatted? No? Okay, it's okay. This is not a big deal. Okay, just think of it as a fancy or the old way of doing cout. Okay, so I'm just doing cout with double quote, the string itself, and then the double quote again. Okay, so we'll check out what this program is going to do. So this is a GCC because it's not a G++ program. It's not a C++. So dash G dash O C str C str.cpp. Okay, and then we just run it. Okay, str, and it just prints empty string and double quote and then a double quote. I forgot to put in a new line, and that's why it did not even open a new line to me. So let's put in a new line, which is \n. Okay. So this is the old way of doing things. Your professor probably wanted you to use your C out and C in for input output, but this is the way that I usually do things. So GCC, GD, just run the program again, C str. So it prints nothing. Okay. So you would be asking, so how do we print something here? So we can say, oh, let's try to make it print TAK, T-A-K, okay, which is my name. I think I did not tell you guys my name is TAK, did I? Hmm? Oh, I did? Okay. So TAK is T-A-K, not T-A-C or T-A-C-K. Hmm? Oh, right. Yep. Yoga TAK and also TAK 10 ADP. That's my account name, and this is my machine name. Okay, so let's do that. Okay. So I want to put my name in the most painful way possible. Okay. So that means I want to put in my name in the ASCII codes. What is uppercase T? Hmm? So there are only a few numbers that you really have to remember, which is just the uppercase A and the lowercase a. I remember lowercase a is 96. Uppercase is going to be 64, I think. So it's 64 and then plus the offset to the letter K. So we have A, B, C, D, E, F, G, H, I, J, K. So that it's plus 10. So that would be 64 plus 10. That's T, uppercase T. And then lowercase a is going to be just 96. And then lowercase k is going to be 96 plus the offset to k. So it'd be A, B, C, D, E, F, G, H, I, J, K. Huh? Yeah, I think the T is the wrong one. I think I forgot. 20? Okay. All right. So if I do something like this, there's a chance that it will print the right thing, but there's also a really good chance that it won't print the right thing because I have not put in the null terminator. Okay, the null terminator is not here. So we'll go ahead and give it a try, okay, because there's a chance that it would actually print out the correct thing, but there's also a chance that it won't. So we'll see whether it does or not. Ah, it does not. And it is wrong because I think I did my calculations incorrectly. So I'm off by one with the K, and then the A is also incorrect because I think it's off by one. I think it's 65 instead of 64. Let's confirm that. Okay, so we'll take a look. Yep, I'm off by one, 65 and not 64. Darn it. I consider these minor details. Yep. Hmm? We just changed the 19 the 20 to 19. There we go. All right, so let's go ahead and run this whole thing again. All right, it did print TAK correctly because before initialization, the string already had the null terminator at the right position. Okay. Okay. Do you understand what I meant? Okay, very good. Okay, I like that because you tell me that you don't know. So it saves me the trouble of trying to read your mind, which I cannot do anyway. All right. So that's good. I like it when people say, I don't know. Okay. It's because if you don't know, you don't know. And the whole point of the class is so that you do know at some point of time, right? All right. So we'll turn off syntax highlighting and list main again. So I'm going to put a breakpoint on line 6, and then we'll put a breakpoint on line 9 right before the printf. Okay. So we'll put another breakpoint at line 9, like so, and then we run the program. All right. So this is before we put anything into any element of the array, okay? Because it's the first line. So what we can do now is we can say print str. So when you print str, it prints a whole bunch of baloney, in out in the output. Exactly. That's the whole thing, right? This is the first character in octo. This is the second character in octo. This is the third character in octo. And then for some strange reason, the fourth character or character three in octo is also \000, which is the null terminator. And that's why it printed out tag correctly because we have enough null characters to begin with. Are we understand this correctly? No, or not? Nope. Okay. So, okay, let me just put something non-zero into these locations, okay? So you can do that in a debugger. It's called setVar, and then you just say which part of the string you want to change. So we're going to change the first character to 56, and then we'll change the second element to um, 71. We'll change the third character to let's say 32, which is space, I think. And then we change the fourth one to 78. We'll change the fifth one to 89. Oops. We'll change the oh, I forgot one. This is the fourth one. We'll change that to 105. And then we'll change the sixth one, which has an index of 5, to we'll make it a I cannot remember what is the bell character. Okay, that's fine. We'll do a carriage return, which is 13. All right. So I have just manually initialized the first 6 locations. So now we have 1, 2, 3, 4, 5, 6. So everything here are no longer null characters. Is that okay? All right, so let's double check, okay? Because we'll take a look at what is the actual content of the string right now. So we say print string, and you see that that's ugly, right? So as it turns out, 56 is the ASCII code of the digit 8. 71 is uppercase G. 32, as I said, is the ASCII of a space, and so on. So are we understanding what we are seeing here in the GDB output? Okay, I see some people nodding. Is everybody getting this part? All right. No? Okay. So when we print string or when we print str, it is printing the entire array. It is not interpreting the string as a C string, which has to be null terminated. It just prints every single character out. So \000 is representing the ASCII code of 0 because it's not printable. Is that okay? So, okay, let me use my mouse pointer here. So what I'm trying to say is um, this was the first character, okay, which is element 0 of the array. This is the second character, which is element 1 of the array. This is element 2. This is element 3, and so on of str. Is that okay? Are we good with that? All right. So after I, intentionally put something into the string, I ended up with the ASCII code of 8 because it is 56, and I ended up with uppercase G because the ASCII code of G is 71. This is the space, which has an ASCII code of 32, and so on. So are we interpreting the output of the debugger? Okay, very good. So now I go through the actual code of my program. Okay, what I just did was to emulate the effect that uninitialized variables in C or C++ can be anything. Is that okay? All right. So now I actually go through my program. Okay, I'm gonna relist the program code itself. So I'm on line 6 right now because I put a breakpoint over there. So now I can single step through line 6, line 7, line 8, line. So we are now up to line 10. Excuse me, line 9, which is going to print. So if I were to continue, okay, if I were to, I don't think I want to step into. Let's put a breakpoint on line 10 and then continue. So now what does it print? It prints tag TAKI lowercase n, and I don't even know where the double quote is because it's supposed to print a double quote, at the end of it. I think it got erased because there might be a backspace thing going on. But anyway, It didn't stop at the K. It did not stop at the K because it did not have a no terminator. Is that concept okay? All right. So the no terminator is really, really important. So if I were to run this program all over again, okay, so I can do run and it starts from the scratch, from scratch. If I were to print str, it is now going back to what it used to be. So the program worked only because the fourth character turned out to be a no terminator from the get-go. Okay, and that's by random. You cannot rely on that. Okay, so that means the program, okay, I'm exiting this. So that means if I really want the program to print text correctly every single time, I need to make sure the following character is a no terminator. We doing okay so far? All right. Yep. Nope. C out would do the same thing. Yep. C out would do the same thing because the concept of a C string is used here, but it's also used in C out. Yep. So every time you hear the term C string, it means it's an array of characters, but the content would be null terminated. That is correct. It is different from the class string. Yep. Yep. The class string is a C++ concept, but C string is just regular C. Yep. Alrighty. So I'm looking at the time. I don't think, I don't know how much momentum want me to go through. So I'm just gonna go through the way that I usually want to go through. Okay, so there we go. This is how you input a string. So when you use cin and then use the operator, this operator to input a string, it is automatically null terminated. So you don't have to worry about, okay, where do I put the null terminator? The input will automatically put in the null terminator. So you don't have to worry about that. Um, so no check to see if there's enough space, and that is a big concern. This is how we end up with buffer overflow type of exploits. So for those of you who also want to get into cybersecurity and whatnot, you want to look up the term which is called buffer or stack overflow. Both of those can be triggered by code like this. Okay, you're trying to input or you read something, you give it a certain amount of space, but the tool or the program or the function that you use to read the input does not care about where it ends because it cannot know where it ends. There's no length that you specify anywhere to tell cin, oh, by the way, you can only input up to 19 characters so that there's one more character space for the null terminator. Nowhere in this particular cin is going to indicate that there's a length limitation. So do not do that. Okay, in commercial programs, do not do anything like that. All right, moving on. Okay, so there's a get line program here for input containing white space to control amount of input. Use get line. And here's a program. Um, we'll try to see what the program is doing. Okay, we have 80 characters in the line array. And we are prompting, okay, so input a sentence with no more than size -1. Why is it size -1? What is that -1 for? The null terminator. Yep, yep, because you can only have up to that with a null terminator. So we can see on line 14, get line is safe to use because you have to indicate how many characters, including the null terminator, the string or the array can store. So that would be the safe way to do it. Using the other way, which just greater than would not be the safe way to do it. All right, moving on. Okay, this is just printing back out what the string has, and this is just counting the number of bytes, I think. Oh no, it is printing out every character one by one. Okay, that's all it's doing here. All right, kind of cool, kind of boring. All right, I'm looking at the time. Okay, we still have about 10 more minutes, so we're gonna go with library functions for working with C strings, and we have to pound include the C string header file. Okay, then that's no big deal. All right, so we're gonna start with the functions. The first one is string length, okay, which returns the length of a C string. So first of all, okay, I'm just double checking here. It doesn't say, okay, that's great. So the first question is the length of a string returned by string length, does it include the null character or not? Because it could be one way or the other. It's only going to be off by one. Oh, shucks. Well, that's depending on you guys, whether you can count the number of characters in there or not. But the answer is no, it does not include the null terminator. Okay. The best way to really find the description of these functions personally is the man page. So I will show you how the man page describes the same function. So you just say man string length, and it is much longer. Okay, compared, well, not much, but it is definitely longer compared to what we just saw. So this is actually, I like this better. Okay, it also very clearly states excluding the terminating null byte. So I like this kind of description because it is a lot more complete and it is also more precise. All right, getting back to the slide, we have string cat. Okay, so string cat is an interesting thing. It's concatenation, by the way. Concatenation simply means you're appending your string two, in this case, to the end of string one. So now the question is, what if string one does not have enough space to accommodate the expansion? Okay, the answer is, well, the function would just overwrite locations that is not supposed to, like nothing. So this is also, when you look at the man page, is actually helpful because the man page would actually tell you something about that. So we'll go ahead and just kind of look at the description. String cat. This function concatenates the string pointed to by source after the string pointed to by destination. The programmer is responsible for allocating a destination buffer large enough that is string length of destination plus string source plus one, which is the null terminator. It probably somewhere it would say do not use it. Okay, it's just not a good idea. Let me see. Uh, Caveats. Okay, well, there we go. If the destination buffer is not large enough, the behavior is undefined. So the question is, are you adventurous enough to discover what it means by undefined? Well, not with my paycheck on the line, so don't do it, okay? So if this is not a good idea, what do we do? If string cat is not a good idea, what do we do? It has a non-evil twin. I guess you can call it an angel twin. Okay, so because sometimes we say that, right? The evil twin. So this time you have an angel twin. So the angel twin is called string and cat. Okay, so the question is, what exactly is the n? The n is the size. Okay, you basically tell it exactly what is the size of the destination. So it will never exceed that number of bytes. Yep. Well, we'll take a look at the description. This function appends at most s size, which is the first parameter, non-null bytes from the array pointed to by source, which is the where you copy from, followed by a null character. So it is always going to be null terminated, but it will only copy at the most s size many bytes. So that's how it behaves. Which means if you know the size of the destination, you can now adjust. It won't overwrite past that point. All right. And I'm not sure whether your textbook actually talk about these things, string and cat versus string cat. Do you guys know? It talk about all the dangerous ones. String copy is the dangerous one. String and copy is the safe one. Okay, same thing. So I can see that it talk about all the ones that you're not supposed to use, and it does not seem to do anything about the ones that you are supposed to use. Yep. For backward compatibility. So, okay, imagine that you are at a company and some code was written 20 years ago. Okay, you still have to know what string cat is, even though it's not a good idea. For if not for anything, you have to recognize it and go like, oh, this is a problem. This is potentially a problem. We have to convert this into string and cat. So that's why, you still need to know it, but I would not put it into a textbook and teach people to use the dangerous version. Yes. Yep. 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 Because so string cat and string copy they came along first, and then people found out that it's really easy to do stack overflow or buffer overflow exploits, and then people realize, oh, that's because we didn't check how many characters we have been copying, and that's when they go like, oh, okay, maybe we should include the boundary in terms of the counter, a count of how many bytes is actually in the buffer. That's when they first start to use string and something. But the textbook apparently has not been updated, even though it is copyright 2021. Pretty sure by the time 2021 came around, the AND version has been around for decades already. All right. Well, we are out of time for the lecture, and I'm not sure what Momena usually do. Does she actually just keep talking, or let you guys do the lab? Give you a break, and then it's up to you guys, right? So what do you guys usually do at the lab? Do you actually do the lab, or does she also go through more? Okay. I don't know where I'm supposed to end. Okay. You know, yeah, yeah. But I don't know whether you have enough to go on for the lab portion for today. Yeah. So let me check the website and see what you are supposed to do today. So do you guys know what you're supposed to do today? All right, I'm just going to search for today's date, which is October 30th. There's nothing on the 30th. There's a bunch of October, 17th, 29th, midterm. Okay. All right, so I see a 31st. Okay, all right, so on October 31st, you're supposed to turn in pointers part two. Do you guys have any questions about that one? You all good? Okay, all right. So it does not look like, there are any homework assignments or lab related to strings just yet. Yes, I did not. It's okay. I wasn't told to do it. Yep. All right, so we're gonna take a break and then I'll be back by about 3 o'clock. I don't know what you guys usually do, but I'll be floating around if you have questions about what you're supposed to do at the lab. Because I don't see any string related lab for today. These are all for November, which is like a few days later. So during the lab, okay. So are those okay? I- Yeah, those are all pointers, right? These are all pointers, and then This is for the string, which she told me would be the topic to go over in the lecture. So in terms of the activities, okay. So I think the lecture is still leading the lab or leading the activities. Okay, okay, okay. So I think there are at least a few pointer stuff that is due after today. Because when I looked it up, there's a quiz here for pointers, November 1st. Okay, gotcha. Okay, all right. Okay, say again. Okay, okay. Yeah, I think okay. I think I'm gonna leave this part to her to turn on because I really do not know what I'm supposed to enable or turn on today. Oh, it does. Oh, okay. So she pre-programmed the release time of the activity. Okay, gotcha. Okay, gotcha. All right. Alrighty. I'm gonna stop the recorder, and if you guys